This one.
It looks like the new button is on.
Okay.
Is it red? Is the button highlighted red?
Red is mute, right?
Yeah, red is muted. Black is unmuted.
Yeah. That's
So you should be able to hear it now, though,
Just have to wait for it to catch
after
up.
the delay.
Okay.
Is everything okay?
Yeah.
Okay, so put your HDMI, please, and you can put your PC.
Get a little bit more space out of this, or is that the limit?
It's stuck here. So come here.
That's probably, let's switch sides then, yeah.
That's HDMI.
It looks like my camera's on.
But there you start sharing your you start sharing your screen. Go to the
Sure.
side.
Go to Google Hangouts, and then
The green button. Yeah, and then click.
okay.
Yeah, I can see that now. All right. Yeah. Sorry, it's all yours.
All right.
And you have the desk phone, the microphone, and you have hand microphone.
Okay. This should be fine, yeah. So, how is everyone tonight?
Fine, thank you.
Good. So, my name is James. I'm a full stack developer at IT Brain. But today I want to talk about getting started with a web app for containers and Docker, and specifically how to use that with .NET Core 2.1. But before we get started, just a quick show of hands. Who here is using Azure?
Yes.
Awesome.
All of us.
Everyone? Yeah. So how about Docker? Who here is using Docker? Okay, excellent. So if I mess up, catch me. And so who's using .NET Core? All right. So a lot of people have not used any of these. How about build? Did anybody watch the build videos or event? Yep. There was a ton of videos, and they're all on Channel 9. So if you get a chance, I would recommend looking at them. But one of the main points that they had was, or one of the big themes was Docker. And one of the most impressive things that I thought was Jeff Holland, the PM for Azure Functions, was showing a Docker image that held a image classifier learning model, and it was pushed out to an IoT camera. So you could be able to classify images or people, spaces completely offline. So I thought that was really, really interesting and something that'd be worth looking into more. Also, in Azure, they have Azure Container Registry, so your own private Docker host. And one of the cool things they have with that now, it's in preview currently, but it is Azure Container Registry build. So you can build your images inside of the Azure Container Registry, and it has all of the great caching goodness. So it's actually really, really quick. Also, there was AKS, Azure Kubernetes Service, was released to GA 2 weeks ago.
Yes.
So very, very exciting stuff for Docker and containers. But what exactly is a container? And I just took a quick definition from the Docker page. And a container image is a lightweight, standalone executable package of a piece of software that includes everything needed to run it: code, runtime, system tools, system libraries, settings. The software will always run the same regardless of the environment. So that's a lot to unpack. Let's go over just some of the basic terminology. So an image is basically the file system. It might also include an operating system, and it also has changes. They're called layers. And then also, of course, your code that you want to run. And a container is an instance of an image, and a layer is a change in the file system that is cached and updated on changes. So with that moving forward, like, why would you even want to use Docker? It's good enough to just be able to just push F5 and debug and then deploy as a zip file. Well, one of the nice things is that you don't have to worry about dependencies for that. You don't have to install NPM, or you don't have to install a C++ redistributable to be able to compile your SAS. That's all inside of the Docker image. So it's actually really useful for development as well. You also don't have to worry about matching global versions of things to your local projects. Python 2 or 3, you don't have to worry about using virtual environment or anything like that. So it's really, really useful. You reduce significantly. It works on my machine type of issues. I'll get to a couple of points to be careful for when using Docker on Windows, but this is actually really, really useful as well. If you are trying to use something that's not supported in Azure, like in web apps, you can't run extremely old versions of .NET possibly, but you still need to have that application running. You can put it in a container and then still be able to use all of the great things about PaaS. Docker images are immutable. So this is also another great thing. Once it's made, then you can have it be put anywhere, and as long as it runs correctly, it will run correctly. The other great thing about this is that if you don't want to be locked into just Azure, or you want to be able to have multiple cloud instances for redundancy, this is also something that can help you achieve that really, really easily without having to dive in really, really deeply into all of these different cloud providers' services. And another thing it's actually really well integrated with Visual Studio 2017 and VS for Mac. VS Code experience is a little bit lacking for debug, but it's possible. So let's take a quick look at a sample Docker file. This is a very, very simple console application for .NET Core. And it will take the base image that is made by Microsoft, and then you will get your NuGet dependencies restored, and then it will copy in your application, and then you will build your application, and then when your image is built and the container is executed, it will call .NET and then the entry point, or the hello.dll. So pretty straightforward. Sometimes these Docker files can get very long. And one thing to note is each of these commands is a layer in Docker. So if it hasn't changed, it will just use the cached version. So moving on to some common Docker commands. Building an image, you give it a T flag for the tag, and then you can give it the image name and then the tag name. When you run the Docker container, you will have quite a few different options available. One of them that's really important is binding ports to external and to the internal image itself. So this will, on your machine, accept requests from port 5000, and internally, inside of the container, it will reroute it to port 80. The RM flag will destroy the container as soon as you stop using it. So one thing that happens a lot when you're developing and using Docker is you'll create a ton of images, and they will take a lot of space. 3, 4, 5, 6, 10, 20 gigs. How many? 60? Yes. So being able to have that deleted immediately and cleaned up for you is really nice. And then, of course, you have your previously built image name. And when you do this command, Docker will actually create a name randomly on its own. If you don't like that, you can overwrite it and put in your own name if you want, but I usually don't care that much. When you want to push an image to a repository, then you have Docker tag and Docker push. So tag will transfer your locally built image and tag to a external portion or to an external provider. And then when you can push that to that provider and be able to access it from anywhere else.
So when you tag, it's just creating a tag.
Correct.
And when you push, it's actually copying the container image from local to the
Correct.
repository.
And it will, of course, check which layers are cached in the registry as well. So you're only having to send what was changed. So what about web app for containers? Like, why would you even want to bother with that? That seems kind of difficult. Why not just use Azure Container Instances or Kubernetes? One of the great things is that it has really good integration with CI/CD, specifically VSTS. Another thing is that this is a PaaS offering. You don't have to worry about updating things. You will have to, of course, update the base image from time to time if there's a security issue, but that is also something that's very, very simple to do. You get slotting. If anybody's used web apps, you can create slots and be able to switch which is running for the slots quickly. So you can have something that you want to release, you switch it, and it turns over immediately. And if something goes wrong, you can switch it back. So very, very useful. Also, you can scale out and, of course, up very, very dynamically, and it's very, very useful. There's also a feature for web apps called authentication. You can block people you can require people to have authentication through Azure AD or Google or Microsoft or Facebook and GitHub, yes. So very, very useful feature that you don't even have to worry about putting into your application. You can have that as an entry point or something that comes before your application is even invoked. And it's highly integrated with application insights for .NET. Unfortunately, other languages are a little bit lacking in their implementations, but for .NET, this works really well. So for web app for container, things that you have to have, and there's a couple things that I forgot that I'll update a little bit later, but web app for container requires a Linux app service plan of basic or standard. And those can get kind of pricey if you're just doing development on them, but that is the minimum requirement for web app for containers. Ken, do you know why that is? Is it like always on is required, or? So for web app for container, do you have to have basic or standard?
Yeah.
What's the reasoning behind that?
We need money.
Well, of course, but there's got to be a technical reason.
No, I don't think so. It's just surprising.
Okay. And you also should have a container registry. Well, you need to have a container registry, either Azure Container Registry or Docker Hub or something else. And of course, you have Docker on your local machine. And because I'm using Azure Container Registry, you will also need Azure CLI. Some things that are nice to have, but you don't have to have them, VSTS for CI/CD pipeline, application insights. And if you're making a Azure Container Registry, be sure to put it in Central US right now, because that is where the Azure Container Registry build preview is available. So with that out of the way, let's do a quick demo with Docker. So, oh, that's really small. Make that bigger. I have a example web application, And it is a very, very simple web application. It doesn't even use MVC. It just takes the request, gets this event, its name, and then sends it back in text. If we look at the Docker file, we actually have some interesting things that I'll talk about in a little bit, but we're taking our, let's get rid of this. We're taking our runtime and our SDK and splitting them apart so we can get a much lighter image. And then we are copying over the CS project files and then the solution file. And then we are restoring it just like in the previous example. Then we build it and then publish it and then create a new image. And this is actually the only part that's kept. And then we have the same typical .NET and then your DLL. So very, very simple setup. If we go to, hopefully this isn't too bright. Let's see here. Build. So I want to build an image. We will call this Meetup.net, and we'll call this the latest image. Oh. I'm in the wrong spot. Just a second. And so you can see that this is building from the Docker file, and every step or every line is every step, and it has a cached item available. Then after that, it is starting to build and restore, and then it is completed. So it should be working once we decide to make a container and run it. So if we do Docker run, let's do Docker run. We need to assign the port. And then we need to also assign the image to it as well, which was Meetup.net latest. And that should run just as is. So if we go to a browser, oh, not that one though. And we have a very small text, but we have the .NET Meetup. And then of course you can see logging while you're running through this. So pretty simple and straightforward, pretty useful. But using it in web app for containers is a little bit simpler. This is a deployed version, and it actually is using some connection strings, which is something that I'll talk about in just a moment. So .NET Core 2.1 on Docker has some really good examples on Docker Hub and what you can kind of expect and need. The key points that I want to talk about this time, though, is multi-stage builds and environment variables. So the .NET Core 2.1 on Docker has separate images available for just the SDK or just the runtime. So that then you can just use .NET Run or just .NET and then your DLL, and it will actually make your application or your images size a lot smaller. I think that this example was only about 250 megabytes, which is pretty quite on the lean side. And so environment variables. There's several ways of doing this, but for working with web app for containers, there's two methods that I would recommend over others. One of them, this is not a method I would recommend, but you can bind file systems to the container and be able to have things dynamically added in as needed. The downside to this is that it doesn't really work well with web app for containers. The bind mechanism is actually used with Azure storage, so it has quite a performance cost to it. Another thing that you can do is use Dockerfile environment variable, or environment tags. So after your Docker run, you would have a tag with a E, and then you'd have your key and your value set in there. And this is the method that I would recommend, mainly because that is how web app for containers binds the portal's application settings to the Docker image, or to the Docker container. And, oh, I guess that's, oh, I'm sorry. So the Docker inv is inside of the Docker file, and I wouldn't recommend this because then you would be holding things in holding things in source code and in your images that is private information. So instead of that, use the environment flag and assign it when you start the container. You can also.
Do we need to define environment key even before we specify -e, or we have to get?
You don't have to do that. And actually, when you look at web app for containers, when it starts up, it takes all of your app settings, keys, and values, and dynamically puts them in with this E flag added. And if you have a bunch of environment files, you can actually create an environment file that looks pretty much almost identical to this. And you can assign it that way. And that would be actually a lot easier to use for development, as it would be able to hold everything, and you would be able to have it on your local machine and not have it in source control. So some tips and tricks. Docker for Windows, be sure to check line breaks. You will get this very, very strange error saying that the executing user process caused an executing format error, which is basically just Linux tried to read the file or the line code and then barfed and then didn't turn out so well. So things like your entry point sh, double check, and be sure to look for that first. Right. And so this is mainly for Docker and Windows. Debugging is possible in VS Code, but you have to create your own task.json, and the configuration is a little bit annoying. Web app for containers logs can be found in Kuzu or in, excuse me a sec, or in the container menu on app service blade. And what that looks like is if we go to our dashboard and we have our app service. And we go to container settings. And this is where you can actually assign which container image to use. And you can check the logs for all invocations. And so this will show you basically what the Docker host would be outputting. Oh, that would be why there's no logs. It's the wrong section. Let's do. So if we go back to container settings, we should have some logs here. And so if you see, there's a lot of environment variables being put into this, including the repository or the registry URL. And then you can also change exactly what it is you have set up in here and switch out a different container image. So overall, very useful. After that, if you do a Dockerfile build, if you try to build your image and something goes wrong, you can actually check which layer, and you can go inside of that image and dig around and see what happened. We can take a look at that actually with this example. So I want to remove the container as soon as I'm done using it, and I want to be able to go inside of it with bash. So we have our layer. And we're inside of the image at that point of the build. So very, very useful for trying to figure out if your paths are right or something's being weird. And so some of you are using Docker. Do you have any other tips or tricks?
You can use it for, the reason I use it is because you can run several different operating systems on the same machine at the same time, very lightweight way, and test to make sure.
Yeah, if we want to repeat for the YouTubers.
We also use it for continuous deployment, kind of continuous integration of things, and it's very useful for, as you showed, you have a first line from, and there's a lot of things you can choose from for from. So if someone comes to me and says, oh, well, this doesn't work on like elementary OS or some weird Linux variant that I've never heard of, I can go and see, oh, do they have a Docker image? Oh, they do. And if I quickly whip up a image that will download and compile the source code on there, then I can, see if it happens there. And actually, in this case, it did. And it's better than going out and, like in the old days, and burning the elementary OS CD and installing it on your machine. So you can quickly test many different variants of Linux if you're supporting that avenue.
Yeah, definitely. Also, I had what was it? I had a project where I needed to work with WordPress, and I didn't really want to put PHP on my local machine, so I created a Docker image and then downloaded PHP and installed it in there and used that, and it worked fine. Actually, they have PHP stock images in Linux, so very, very simple and easy to use.
Yeah, we also start supporting SQL Server on Linux. So that might be a good candidate to use with Docker.
Yeah, I just finished up something similar to that. So I believe that's everything that I have for my presentation. If you have any questions, ask me, and if I don't know, I'll ask Ken.
Yeah, thank you. Yeah, there are many reasons why you want to study or learn Docker, because it's kind of basic or base of the development for the future. Whenever you use Kubernetes or any other things, of course, it does not work with Service Fabric.
Right.
But I think Docker is a kind of basic technology which you really need to study. And for Visual Studio, you just need to check one box, check box to make this project Docker aware, and that's it. That's easy. And you really do not see that much difference as long as you're running on local. Yeah. All right. Thank you.
Pro or above, so you can use hyper whatever, hyper-V.
Right.
But then be careful about if you're also trying to run the Android emulators, they'll complain if you install Paxum and hyper-V at the same time.
All right, so can someone confirm the YouTube that you see Meetup page? Do you see that?
Somebody is echoing you.
Good.
All right, so do you see the echo? No, right, because I keep kicking out.
Yes. Yeah.
All right, so okay, so with that break, let me just resume the session. And after this one, we take kind of 5-10 minutes break, then I continue the following session. So how many of you in this room are very new to .NET framework? You are not. 1 year, 2 years, 3 years, more than 10 years. All right. So yeah, so I assume many of you are familiar with .NET. The reason why I bring up what's .NET 1.1 is because we had several new people to the meetup last time, but I think this is still kind of relevant to everybody, even though you are 10 years player, because sometimes you're only working for what you're assigned to, and you sometimes forget about the basic. So just let me go through very quick about this topic. So what I want to talk about in this session is I really would like to explain what is .NET. I mean, when you say .NET, what does it mean? People say it's framework. People say it's execution runtime. People say it's kind of CLR or LI. So I just try to explain what it is. It's a life, yes. All right, so the basic terminology, so there are so many terminologies for .NET, but these three are very basic. CLI, CLR, a very different pronunciation for Japanese, and the .NET framework. The relationship is like this. The .NET framework contains CLR, which contains CLI. Then let's start from the smallest one, the Common Language Interface, CLI. So I don't want to read, but let me read anyway. So multiple high-level languages to be used. In this case, we are talking about like C#, F#, VB.NET. So we have multiple types of the language supporting .NET. And so multiple high-level languages to be used on different computer platform, meaning maybe 32-bit, Windows 64-bit, or ARM. So we have multiple platforms without being rewritten for specific architectures. This is the best part, because once you write, that your program runs everywhere. So that's the basic concept of the program for .NET. And we had similar idea before, like Java. Java has a virtual environment which runs everywhere. So what's the difference? Difference is we can support multiple languages. This is very unique to .NET from my understanding. There may be some languages or the programming model supporting multiple languages, but .NET is very unique because you can run F# if you want, or you can write VB.NET if you really want, and I can write C#, but everything compiled into the exactly same language and running on multiple platforms. This is cool. Now even we have .NET Core, which also supporting Linux as well. All right, to make it happen, we have the common language interface, because when you have multiple languages, we have some promise. So this is the interface you have to adhere. Otherwise, if everybody wants to do something different, it's totally different language now, right? So what we agree is a common type system. So common data types between languages. So if I say integer, it's integer. If I say integer 64, it's integer 64. Yes, we have some difference between VB.NET and the C# integer, but it's kind of subset. And another one is metadata. This is very interesting from the debugging point of view. So when we compile something like C++ application into the .exe file, that one does not bring any metadata, meaning when we debug for the memory debug, I have no idea what it is without any symbols. You may know what I'm talking about if you do the debug, but .NET or managed code bring metadata with it, meaning that .exe, the executable, contain all the information about your programming or your source code. And when I say information, meaning class name, method name. So without any symbol, we can do some sort of debugging by using the WinDebug if we want. And another one is common language specification, a set of base rules for different languages to ensure interoperability. So this is interesting when you do like IL-SPY. If I compile C# programming into intermediate language, then if I decompile back to VB.NET, I can do it, right? And another thing is virtual execution system. This name applies, we can execute our program virtually. So all the information comes from this Wikipedia. So just check up this Wikipedia, and if you see some information is wrong, you are very welcome to contribute to update the Wikipedia. That's what the Wikipedia is for. All right, next, CLR. So common runtime language runtime. So it was common language interface. Now it's common language runtime. So CLR is a spec, right? And CLR is implementation. So CLI is more like documentation. This is what you need to do. This is what you should do. I don't know if there is a should do part, but this is something you need to do. The CLR is one way of implementing that CLI. So CLR implements the virtual execution system as defined in the CLI. And what CLR may contain is generate CLI from the programming and JIT compiling. JIT stands for just in time. And it also does the memory management, meaning not only allocating, but also garbage collection. And manage types and assemblies, threading, exception handling, security. So there are so many CLI defined stuff which CLR have to support. And if you really want, you can write in your own CLR. Actually, there is one open source project for you, which is slightly different from .NET 1. All right. Then common intermediate language. So what happens is, so we already know .NET support multiple languages like C#, F#, and if C# compiled into the native, the machine code, what happens? I need to compile target into specific processor, right? Because processor, 32-bit processor, the what's the name of the command set?
x86.
Yeah, so x86 command set. And when we're targeting ARM processor, they are not compatible, right? Because it's the native code. So what .NET Framework does to support multiple platforms is to compile into intermediate language, which can be compile it again later on to meeting the real CPU for the platform. All right, so CLI executes on virtual environment, then JIT compiler actually compiles CLI to native code. This is one of the reasons why .NET program runs slow the first time to execute. Because when you execute, even though it looks like .exe file, it is not compiled in native code. It is still in the intermediate language code, and they have to compile it, not again, but compile it to the native. But from second time, because it's already compiled, it runs great. Why we want to do that? Because to support multiple platform, yes, and another reason why is because whenever a new CPU comes in with a better command set or a new feature with the CPU, we would like to using the latest command set so that we can execute the code as quick or as fast as possible. Then, if we already compiled, compiling meaning you already decide which command set you want to use for the CPU. But if we have opportunity to recompile or dynamic compile by noticing which CPU this computer is having, then we can optimize the code. So that's the basic idea of CIL. By the way, the common interface language are the three. IL, before we call it MSIL. So this is a basic architecture. So on the left-hand side, source code, you can pick up any source code, C#, VB.NET, F#, other .NET language. And if you really want to create one, you can just make up something like Gymboard.NET or J#. Then everybody has its own compiler, C# compiler, VB.NET compiler. They are not compiling to native code, but they are compiling to intermediate language. That's why this CIL could be decompiled to C# or VB.NET. Or when you compile your code to IL, and if you try to decompile to C#, so you start from C# and you try to go back to C#, but your source code may look different depending on which decompiler you are using. Sometimes which makes it better from the readability point of view. So you can play with the decompiler like ILSpy. Richard, do that? Yes?
Yes, .p.
Yeah. Then the CIL code is compiled into native code when runtime. But to make the performance optimized even for the first time, of course, the .NET framework support native compile by specifying the flag. Because if you already know which CPU you are running on for your program, you do not want intermediate language, right? Because you want to compile down to native. So that when runtime, there is no additional cost to compile it again.
Sometimes you have to.
Sometimes you have to, yeah. And for example, Windows 10, Windows Store, when you're submitting the UWP application to the Windows Store, Microsoft do the analysis of which platform you are supporting, and it's native compile in the store side. So whenever you're downloading to 64-bit or 32-bit, already compiled one is downloaded to your Windows 10, so that users do not have to wait to compile for the first time. So we do some optimization. All right, move on. .NET Framework. So what is .NET Framework? .NET Framework including CLR and Framework class libraries. As I already mentioned, CLI is the interface and CLR is the actual implementation. Then .NET Framework contains, of course, CLR because we need to run the program, but as well as other framework class libraries. And it also comes with different flavor of library depending on what kind of program you are doing. So maybe CY, GY store application, more like client side, or ASP.NET, ADO.NET, WCF, WF, WPF, MVC, and RIP, Silverlight, Light Switch, SharePoint, SQL Report. So we have so many different types of .NET application, and we are providing framework class libraries or SDK for each platform. Does this make sense? Yeah. And we have .NET Framework versions. So .NET Framework 1.1, 2.0, 3.0, 3.5, 4.0, 4.5, and there it is now 4.8 is the latest, right? 4.8 to 1, I don't know. And we also have .NET Core. If you look at the Wikipedia, this page, it has all the detail when which version has been released. All right, so that's a basic idea of the .NET framework. Now move on to intermediate language and the JIT compiler. Not much demo, but this is a C# program, right? So if I open up my Visual Studio Code, and so this is a C# code. And this is just a plain text at this moment, right? And usually, if you are studying C++ or any other language, if you compile meaning compile down to native code. But .NET Framework do not compile into native code without specifying any flag. So we compile down to intermediate language. And we are providing the command line compiler CSC. And once we compile it, we can have the execution file, as you can see here. So I have source code, and I also have execution code. And if I open that one by using the special program called IL-dozen, and this is IL-dozen, it's intermediate language disassembly, and open the file, and this is the one. And if I open the main programming, so this is IO. Let me zoom in. Oops. Where's my code? I can't see why. Oh, by some reason, I cannot zoom into it. So I hope you have good eye. So this is a source code, and this is an intermediate language. So this plain text is compiled down to this intermediate language. And this intermediate language does not run on any platform as this form. So when we run, JIT compiler, just-in-time compiler, comes in to compile this one down to native code. In my case, my computer is 64-bit Intel, so they are using that, the command set to compile. So as you can see, I said console write line hello world, and I believe you have a capability to read what it does, right? So we are loading the string to the stack, and we are just calling the method by using that, the parameter. Done, easy, right? If you have any question, just let me know. So this is IL-dozen. By the way, it also have the manifest. So if I open this one, and if I double click this manifest, it say this is the public key, blah, blah, this is the version 4000, and the assembly name is the learning C#, and it has constructor. So this is the kind of the part of the metadata I was talking about. So without including any symbols, .exe, .execution file already contains some information about this program. This is very helpful when you debug without any symbol. All right. Now let's move into object and memory management. By the way, I do not talk everything about .NET Framework. I just pick up something it may interest you. And for .NET, we have two types of the object. Object is something created in the memory. And we have value type and reference type. And value type, as the name said, is value. And the store value in stack. So in type, double type, datetime, struct, or enum are the value type, the example of value type. So what do I mean? The value stored in the stack. So whenever a program is running on the thread using stack to tracking where they are. So when they calling a new method, they put some variable before the method call. And at the end, they put the function which called the other method. And that one is taking the variable from the stack, right? So if the value is int or double or datetime, like value type, actual data is stored inside the stack. What does it mean? When method needs value, they can directly access the value inside the stack. That's the one thing you need to understand. Another thing is if you're calling another method inside the method, once the method has been done, it's coming back to original stack, right? Then all of the allocated object will be gone without the garbage collector try to collecting it because it lives inside the stack, not lives in the heap. So this is good for the performance, depending on how big the value is. And boxing. So the value type, as I said, lives in stack, but for the C#, we can casting the value to something else. And every object in .NET Framework is inherit from object. And if object is reference type, not value type, so if I put int value into object, it becomes object, meaning value type becomes reference type. As soon as we do that, that value is copied to heap as object. So that's called boxing. And we have another word called unboxing, meaning whenever we try to get the value out of that object, which is int, by the way, we are unboxing the object. Does it sound performance well? No. So you should try avoid using boxing, but you need to understand what .NET Framework does for value type converting to reference type. So that's boxing. And what's the reference type? So reference type from the stack point of view, inside the stack, we do not storing actual data in the stack because it's not a value type. So what we have in the stack, we only have the memory address or AKA pointer, right? And that pointer pointing to the object in the heap. So in the stack, we only have the pointer, and whenever function tries to get the argument, it sees the pointer and go into the heap to get the data, then they can do whatever they want. So there are some overhead, but if the reference type, the reason why is basically the reference type is bigger than value type, and it's not a great idea to store everything in the stack. Why? Because each stack has its allocated memory size. For example, 1 megabyte. And if you keep calling the method inside the method, stack keeps stacking up. That's why we call that stack. And if stack using entire memory of allocated memory, which could be 1 megabyte or even less, then we see that reference type is we only storing the pointer, then the actual memory is allocated in the heap. What does this mean? When we finish the method and with the stack coming back to original stack pointer, we only deallocating the pointer address, but it does not mean we are cleaning up the object in the heap, right? The object still lives in the heap. And for C++, you have to clean up by yourself. But the managed code, the great part of the managed code, I'm not quite sure it's great or not, but the good part of the managed code, the developer do not have to clean up the object by themselves, but the garbage collector does it for you. All right, so what is a heap or managed heap? When we say just heap meaning a bunch of space in the memory, that's a heap, right? But when we say managed heap, this is a heap created by CLR, and the CLR is the one to managing this heap. So .NET Framework manages its heap by using heap manager, and objects in managed heap are managed as a generation. So let's say if I do some new, so my class A equal new my class, as soon as I did that, a object is created in a managed heap. Then we mark it as generation 0. And sometimes later, garbage collector comes in to try to collect garbage. But what if my object is not garbage, meaning still reference from something else? We call that rooted. If the object is rooted, garbage collector cannot collect it because it's not garbage yet, right? And what if later on garbage collector comes next again to check the object if it's rooted? Comes again, check if it's still rooted. It's kind of waste of the time to keep checking if it's rooted, right? So we are marking generation 0 to 1 if it's rooted yet. And the garbage collector check generation 0 more frequent than generation 1 so that they can save time. But sometimes later, garbage collector have to come to generation 1 to check if some of the object lives there is rooted or not. If it's rooted, they mark it generation 2. So generation 2, garbage collector comes in less frequent. So they go to generation 0 a lot, generation 1 a little, generation 2 not as much as other generations. And do we have generation 3? No. At this moment, no. We have 0, 1, 2. And the reason why we classify that way is just try to let garbage collector do their job rather than just checking and mark it. This is still using. This is still using. This is still using. Does not make sense, right? All right. And the garbage collector deletes not rooted object only and reclaim the space later on. Then we have 2 types of managed heap. One is the short-lived object heap, which is generation 0, 1, 2, as I said. So whenever the object instance size is less than 85 kilobyte, we place the object into the managed generation 0, 1, 2 heap, meaning garbage collector gets there to collect the data or delete the data. And we also have different heap called large object heap. So when I create some object which is larger than 85 kilobyte, we place that in the large object heap. And the garbage collector, of course, checking the heap as well. And whenever object is not rooted anymore, they are deleting. So what's the difference of these two? Because the garbage collector are going there to delete object anyway, right? The difference is the first one, garbage collector try to defrag the memory. So let's imagine you have 100 objects in the memory, and 50 of them not rooted anymore. The other garbage collector, you want to delete these 50, right? But these 50 objects does not have to be consecutive order, right? Sometimes 0 is used, 1 is not used, 2 is used, 3 is not used. So when you delete it, it's fragmented. And you keep losing the consecutive memory space, which meaning even though you still have space, you may encounter out of memory space because sometimes .NET say, I need 4 megabyte. And even though in total, there is a 4 megabyte space, but there is no consecutive 4 megabyte space and you encounter out of memory. So the garbage collector not only deleting the object, but it also try to compact or defrag the memory. That we are doing for generation 1, 0, 1, 2 heap. But for the large object heap, we are not doing that. Just keep it as it is.
4 megabytes.
4 megabytes, yes. 4 kilobytes, sorry. 4 megabytes going to large object heap for sure. All right, so another thing we need to understand is GC also has the type modes, meaning whenever I do garbage collection, there are 2 ways to garbage collect. One is server mode, another is workstation mode. The server mode meaning garbage collector is having its own thread, garbage collection thread. And workstation mode is like garbage collection is running on top of existing current thread. And the server mode, what they did before .NET 4.0 is, let's say there are 20 threads, and the garbage collector 1 thread. By the way, 1 thread per CPU. And there is one garbage collector thread say, okay, please, everybody, do not move. Then they delete object and compact everything. And after it's done, all right, resume your work. That's how they collect data. But why do we have to suspend all the execution of the thread? The reason is because we are compacting the memory. We defragment the memory, right? What do we mean, defragment the memory? Meaning we are moving object to different address, meaning we are moving the pointer, meaning we have to updating all the pointer reference of the current thread. Otherwise, if we just move the object somewhere, and the thread try to accessing to the address, there is no object there, right? Because we already moved, meaning we have to update the thread. That's why we have to asking all the threads to stop working Does it make sense? Yeah. And the workstation mode is more like we cannot freeze entire thread because the people confuse. Because your PC all of a sudden stopped working for 2 seconds, 3 seconds freezing, right? So GC performance has a kind of the big topic for Microsoft to try to optimize it. So before stop all thread when GC and performance decrease depending on amount of memory to be released. So if we only collecting maybe 10, 20, 30 objects, that should be fine. But what if we need to collect millions of objects this time? So we cannot estimate how much time we need to do the correction, right? So performance improvement for the .NET 4, the garbage collector thread can be running on the background, and it only does for workstation for .NET 4 and .NET 4.5. Server also using background mode for the garbage collection. Then, when we have a managed heap, there is an unmanaged heap as well, which is just normal other Windows heap. So if you can write some code only with C# without using any unmanaged code, that is great. But sometimes you need to do p-info stuff, like Jim do all the time, which meaning that object is not managed object, which is unmanaged object, which is just normal other Windows object, right? Then managed object, the memory manager have no idea about that one because it's not allocated into the managed heap, but it's allocated into another heap. So garbage collector cannot handle unmanaged resources, so use the deconstructor to release them manually by developer. So as a developer, if you are using unmanaged resource, you are the one who have to release it in, explicitly. Okay. So garbage collector release object asynchronously, so not sure when they are disposing. So from developer point of view, as soon as you are not a reference object anymore, you assume object will be deleted, which is not true because the garbage collector may run right now or may run later, right? And so you can implement a disposable interface to make some work. So deconstruct and finalizer. So when your class has a deconstructor, regardless it has something to do or nothing, then what's happening is when it initialized by using new keyword, it recognizes the finalized queue. So the .NET framework or CLR recognizes it as this guy has to be going to finalize queue whenever it's disposing because it has deconstructor method. And then when GC'd, when unrooted, it is subject to finalizer. So there is a finalizer thread, do all the things about finalizing. So garbage collector, because the garbage collector cannot release a managed object, they are just put into the finalizer queue. Then finalizer is the one to checking all the unmanaged object to release everything. But you can do that with dispose method explicitly so that you can release it when you really need. But garbage collector has no idea if you have done that or not, right? That's why in the dispose method, if you releasing the unmanaged resource, you have to call this dc.suppress finalize method to let the garbage collector know, or this is already done. You don't have to do anything. All right, so that's a basic idea of the memory management. Okay. This is a basic. The reason why I said this is basic is because I did not bring up any wind bag. So, all right. So the original plan was take a break here, but because I don't have enough time, can we just go ahead? If you need a break, just go ahead to take a break. But I just go ahead. I just continue my session. I have 5 questions, 1, 2, 3, 4, 5 for you to answer for the next presentation. Why your code runs fast or slow? This is very important for the developer to understand why the code is running faster than others or slower than others. All right, first question. Which is faster? Appending string to existing string or use string builder to append the string. Show your hand. The first one is faster. Second one is faster. All right, so Jim, why first one is faster?
I already know the answer because I actually looked this up the other day.
But the thing is, you are wrong.
What? I did a benchmark on this and they showed it.
No, you are wrong. Sorry. Yeah. So it really depends. But I do not like the answer. It depends because that's the ultimate answer, right? It depends. Everybody knows that. All right. So let's do some testing by specifying more clear condition. And why this is all small. String this class. All right, so what I'm doing here is I have 3 test methods. So first one is a simple string test, meaning I create one result string, then I keep pending A to it for 400,000 times. Okay. The second one is I'm using string builder. So first of all, I need to create string builder instance and keep appending A to it and just counting the number, okay? All right, so let's see which is faster. Ooh, I can't run with there. All right, so there is a run method. Maybe I put some wrong keyboard shortcut to make everything lowercase. So what this does is every 100-second time, it's putting the millisecond. So this is our fast test, just string, keep appending A. So 100,000 to second, 200,000. By some reason, it tripled the performance 6 seconds, and 300,000, it's kind of 12 seconds. It's not accumulated, it's remeasuring the performance. So if the variable is bigger, even slower, right? And where is the 400,000? Come on, you can do that, right? All right, so as you can see, string builder does it with 2 milliseconds. And string does it for like 32 plus 12 plus 6 plus 2 seconds. Why? Why string builder is so fast compared to string?
There's some trickery here.
So string type in .NET is immutable. Immutable meaning you cannot change it. But we are changing it, right? Because we are appending A at the end of last one. So what is happening if we are doing that for the immutable object? Yeah, create a new one. So we are creating a new one by adding A. So at the end of 400,000 loop, how many objects created? 400,000. On the other hand, what string builder does is when it initialized, it gets allocating some memory and keep reusing the space to keep adding the string. And only if it's out of memory of that initial allocation, it does do the second allocation. It's not immutable. That's why it runs so quick. But why you want to use string sometimes than string builder? As I said, string builder pre-allocates certain space. And if you already know you do not append anything for your string, you better use a string because it's only allocating the necessary memory compared to string builder. String builder allocates a bunch of memory regardless if you are using it or not. So this is a good and bad part. All right, next question. Which is faster, loop using for versus loop using for each?
It depends.
It depends. All right, let me change the question. If you are using list generic collection, doing the for versus for loop, which is faster? All right, for each. And you should raise your hand for either question. Or you say exactly same? Maybe. All right, let's figure it out. So this time it's a loop test. And while it's running, let me go back to this loop test to see the definition. Wait, it's trying to compile. Yep. So what I'm doing in this loop test is I have 40 million count at loop 10. And what I'm doing is creating the array and the list of int and int of array, and to prepare the list with the 40 million. The first one is using for I2 loop count and using the for each for the values, right? And the second one is using for I2 loop count and using for inside the object as well. So the first one using for each, second one using for. All right, so this is the result. For testing, 90 milliseconds, 100 milliseconds, 100 milliseconds, 81 milliseconds. So it's kind of average for 100 milliseconds. And for each, it's taking around 200 milliseconds. Why? Then another test I was doing actually is even though I'm doing the for each, I'm using array rather than list. In that case, what is happening is it's around 100 milliseconds. So even though for each, if that array type, the performance is same, then why list taking so much time than array? The reason is because if you're using list, if you do the for each, it generates I enumerable object, and how I enumerable object go into the next object is going to call in the move method. And every time it calls move, it tries to see if it could go into next one or not by checking Boolean result. So every time it checking the next one, it's calling another method to confirm if actually it could move to the next one or not. That's the additional overhead. Make sense?
Does the array skip that?
An array, because array do not generate AI enumerable. So if you compile and if you see the intermediate language, it's exactly the same.
That's the compiler optimization.
Yeah, compile optimization, yes. All right, next one. Which is faster? Create classes and add to list, or create structs and add to list. All right, the first one, classes are faster. Second one, structs are faster. First one?
Which is creating the class?
All right, so let's figure out which is which.
Creating the class. I think the class is obviously faster. That's the problem.
Yeah. And for this one, what I'm doing inside this class struct test class, it sounds a bit. Yes, it sounds like a joke. So class struct test class. So what I'm doing is I'm again creating, first of all, I declare this is my class, this is my struct, which is exactly same, just X and Y. And by the way, I also have the class with the T constructor, which I was talking about. And the first one is testing the class test. So I am using the list class, and I keep adding to the list. And second one is class with finalizer. And the last one is a struct, and I keep adding to the list. So I'm doing exactly same stuff for these three. Then the result is the first one taking 6 seconds. The second one with the finalizer as a deconstructor, taking more time than normal class. The struct is way faster, way faster than class. Why?
Don't they include the time to destroy in the
A destroy may happen by the object creator, and we don't know when it's running. The reason is because the struct is created on the stack, buffers, blah blah. So what does this mean? Meaning that whenever you create class, you have additional pointer generated, right? So that's the overhead. And how about the constructor? Because it's not disposed yet, right? But when it initializes, it has to mark it to finalize queue. So that's additional work there, right? Even though that the constructor does nothing. So if you don't do anything, do not write it, okay? Why you're writing that? Because it comes as template, right?
What if the struct had like 16 entries inside of it?
Yeah, so that's another question. So if I say just struct or class, we cannot. Anyways, I hate the answer. It depends. So.
Better questions then.
Yeah. All right. Next and the last question, I guess. No, not last. The next question: if we have byte array, 2 byte arrays, and I want to copy everything from first one to the second one. Which is faster, copy byte to byte or using copy to method? First one, copy to method is a buffer method, buffer.copy to. The first one, second one.
I vote for buffer.
Yeah.
It's like the fastest way to copy anything.
Sure. So let's see.
Basically, just copy.
Right. Red start, and coming back to buffer copy test class. It's compiling. All right, so this one, what I'm doing, I created 2 buffers. And the first one is just checking each buffer from buffer 1 and moving to buffer 2, not moving copy to buffer 2. The other one is just using the buffer 1 copy to buffer 2 by specifying where to copy. Third one, actually, we have another buffer.block copy. But then answer is, actually, these 2 can be same with effect. So if you do one by one, it's way slower. So there is some optimization mechanism inside. And I don't know why, but you may want to look at the open source version of this copy to see how well this performs. All right. So finally, the last question, last but not least, which is faster, using the parse versus using try parse for, let's say, int parse versus int try parse. And if I ask in this way, it may not make sense. So I show you the code. I'm showing you the code right now, parse. So let's say we have the array having 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, like this as a string. And I want to parse it. And if I parse, I have to try catch, right? Because I don't know if it can be parsed or not. And if I do try parse, I don't have to. And I'm just adding everything which could be parsed to prove this generates exactly the same result. All right, so which is faster? Try is faster. Oh, sorry, parse is faster. Try parse is faster. Why try parse is faster, by the way?
I think because it doesn't throw an exception.
Yeah, and the throwing exception is expensive.
But I don't think.
So throwing exception is expensive or not?
Yes, there is.
Why?
Because it intrudes.
Because that exception object itself including so many information anyway, right? And it's calling another layer of the method, so it's another stack. Right? Does this run? Yeah, it should be running and doing their work, and you should see the result later. So anyway, so whenever you have try pass, do that, or try to avoid try catch. If you already know catch is going to be covered anyway, right? All right, come on, show me the result. Show me the result.
You can lower your count of runs.
Yeah, but if I'm making the counter too low, we don't see the difference. All right, so the total result is the 22, what's this one, 1,000, and it take 55 seconds. And for the try pass, the result is the same, right? Because we are only accumulating the past result, and it already took 1 millisecond. Yeah.
Okay, but if there were no errors, if everything.
And if there is no errors, what's happening, you can try later. But the reason why we want to do the try pass is because there may be some errors, right? That's the parse, the trick parse anyway. All right, so you should avoid throwing the error. So do not depend on try catch. Sometimes we have to because there is no try kind of stuff. But anyway.
I still think there'll be overhead for the try catch even without an exception.
Yeah, could be. Yeah, we can see it by implementing the test. But the reason why I'm talking about this performance stuff with the .NET 1.1 is sometimes we see so many best practices. This is a code you should write. This is things that you should do stuff, right? But you have to, or we have to really understand why this is faster than others by knowing what .NET Framework really does. Why? Because sometimes newer versions of .NET Framework do it differently. But the basic idea is the same because type only 2 types, value type, reference type, and there's a managed heap, unmanaged heap, garbage collector, right? There are so many things very basic which affect performance. So whenever you see best practices, just try to think or try to research what does it mean for your programming. It is faster because it does not allocate memory, or it is faster because blah, 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 right?
Faster because it allocates more.
Yeah. Do less, better performance, obviously. But we need to do something to make program running anyway. So this applies for SQL Server or SharePoint or any other programming. But yeah, we just need to understand what's happening behind. Or just pay more money to get the better computer, which may eliminate your performance issue, right? It depends. All right, that's it. Thank you. All right, so let me stop the presentation and let me stop the